Homework 5, problem 2, find the charge density sigma of z on the two charged plates for the same problem that we did for problem 1. To start out, I'm just going to write down what we know about the potential for problem 1, and so this is what we found last time. So I'm just going to copy this down. We have that v of y and z is equal to sum, where we skip in sets of 4, 8 v naught over n pi exponential of minus n pi over a y times the sine of n pi over a z. Now, in order to find the charge density on these plates, I'm going to notice that these plates are conductors. Since they're conductors, if I want a charge density on the surface of the conductor, I can use the electromagnetic boundary conditions that says charge density is equal to n hat dot then epsilon naught times E above minus epsilon naught E below. In our case, since these are constant potentials, I know that constant potentials behave like conductors, and in conductors, the electric field just below a surface of the conductor is going to be 0. So I'm going to set the E below to be 0 in this case. As I continue through this, the next thing that I would notice is that n hat for us is going to be in the positive y direction. And so this is simply going to say that the sigma is equal to epsilon naught times the y component of E for us here. But the y component of E is minus epsilon naught times the derivative of y of our potential, y z, and we have to evaluate this at y equals 0. And so this is what we have to evaluate in the end. This is actually really trivial. The partial derivative of v with respect to y is just a partial derivative of an exponential. And so minus partial over partial y of exponential of minus n pi over a y, and if I think of having a 8 v naught over n pi out front, this is going to give me 8 v naught over n pi. I'm going to multiply by what I have here. So I have the minus sign there is going to cancel. This is going to give n pi over a times exponential of minus n pi over a y. And so the n pi's are going to cancel, and I'm going to get a factor of a out. And so that says that sigma, oh, and the last thing that we're going to look at, right, is this is going to be evaluated at y equals 0, evaluated at y equals 0, which is itself 1. So sigma as a function of z between these two plates on the surface of these two conductors can be given by the expression sum n equals 2, 6, 10, dot, 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 8 v naught over a times the sine of n pi over a times z.